Hello there, I'm Alessandro, your astronomer next door. So today I want to give you a non-exhaustive list of websites that astronomers find very useful. I guess one thing that you may believe is that we check the NASA website every morning. It is not completely true. As a European, you may believe that I check the ESA website every morning. Also, not completely true. And so the ones of you who are in the tech universe may think that, we use Google Scholar. Google Scholar. So Google detects that I am based in Spain, so I have it in Spanish. And yes, Google Scholar is used, but it's not as used. The real tools that we use for bibliography are others. And perhaps the most useful one and the most used one on a daily basis, literally, is the arXiv. arXiv was originally based in Los Alamos National Laboratories. The ones of you who seen Oppenheimer last year have seen how the laboratories were born. It recently migrated to Cornell University, and over the years it has grown, and it serves multiple branches of physics and science more in general: biology, statistics, electrical engineering, economics. Let's focus on the astrophysics bit. In the astrophysics bit, it gives you a lot of content, and you can subscribe to receive emails on a daily basis. And so this is very useful. You don't want to have to go on the website every day. Much easier to receive the email once a day. And once you get the email, you can look through it, and in case you have 2 or 3 days you're traveling, you cannot check the website, the email is always with you. Advice: don't let these emails accumulate, you'll never catch up. And what I do every morning is I go through this and I go through this list and I check if there's anything interesting. For example, this is one of the papers I checked this morning, so you can go check the PDF of the paper. There's a the important thing here is you get a lot of information, and one of the most interesting bits is these comments. It tells you that, for example, in this case, this paper was accepted by a refereed journal. So this means that this paper is reasonable. Other papers which don't tell you if they are submitted, if they're accepted. This one, for example, is just submitted, so perhaps I would wait a little bit to make sure that the paper has been checked by other colleagues. Maybe at some point I will make a video on the publication process in astronomy, which anyway is very similar to other cases in other science. Another very interesting and very useful bibliographic resource is ADS. So here it goes. A couple of years ago it changed its feeling. When I started my PhD, it was much more similar to what you're seeing on the screen now. The modern form is this one. So I want to give you an example of how it feels. So let's check with a very famous author, Leavitt. So Henrietta Leavitt, possibly one of the most brilliant astronomical minds of the 20th century. In this case, I searched for her papers, and I get a lot of other people. So what I can do is I can filter so that I only get her papers. So once I filter only by the name Henrietta Swan Leavitt, I get the 82 results, 82 papers that she published. Also, I get a nice histogram of the number of papers that she published every bunch of years. It's very interesting that there is this paper that was published posthumously, and you can list the papers by chronological order, with most recent first, latest first. By citation count, there are people who believe that citation is a tracer of quality. Not necessarily, but if I'm not mistaken, this one is perhaps one of the most important papers in the history of astronomy, and you can see it only has 286 citations. You can also use, and this is I find quite interesting, you can use what they call the classic factor. Is a factor created by them which combines citations, searches. Is where ADS actually behaves like like a search engine. Another very funny thing is you can use this once you have your paper selected. Right, you can come here, you see the paper, and you can click on these links on the right to get access to the PDF, like so. Right, so here it is, and this is the plot, the original plot of the period magnitude relation, and then you can use export citation when you are writing a paper and you want to include this in your article. You can use this and export in the format you prefer, or rather the format that the journal you're writing the paper for is expecting you to write the references in. If you want to really have fun, and this is just playing around, you can explore the numerology of this author, in this case Henrietta Leavitt, and you can see the citation metrics, and you can see how many papers she published, the number of citations, the number of reads, and you can read the indices. So if we are done with bibliography, where do we find information about astronomical sources? The main place for it is Simbad. Simbad is maintained by the data center of Strasbourg. I will not dare to say it in French. And once we look for our favorite object, let's look for StScI, we get a type, all its different possible names, the coordinates in different reference systems. We'll go through the reference systems in another video. Proper motions, radial velocities, magnitudes. We even get this nice tool, Aladdin Light, to be able to see where the object is. and we get all the bibliographic information, and most of this is automatically generated. When I say most, is because actually this is maintained. So there are people at the data center of Strasbourg which actually go through these objects and maintain it, and in some cases when there are errors, they fix them. In case your interesting object is not a star but is an extragalactic object, Simbad does a very good job, but perhaps your real resource is the NASA Extragalactic Database. This is a NASA resource, is maintained at Caltech, and it has actually a very big deal of very interesting and very useful services, and a series of tools like coordinate calculator, which allows you to transform between different coordinate systems. Nowadays you can do it in other ways, but this is a good one. Extinction calculator allows you to compute extinctions. It used to have, and probably still has somewhere, some introduction to astronomy. And if you look, for example, for your favorite object here, and in my case I would look for M87, which is one of my favorite galaxies, it starts the search, and it gives you most of what you normally want to look for. So it gets you the name, the coordinates, the size, the position angle, which is the inclination, the distance in terms of redshift and in terms of megaparsecs, type of object, morphology type, and it also gives you where are they? The photometry and the spectral energy distribution. It's very complete, and it's very well done. But what if the object you care for is moving? So objects of the solar system. For the object of the solar system, again, you have to stay in the United States. So you go to JPL Horizons, which is again, this is also from Caltech. This is a JPL, and this allows you to compute the coordinates of a specific object. Let's say we want to compute the coordinates of Jupiter over the next month, and we just select generated families, and yes, this is red ascension declination of Jupiter for the next month, and that's also the brightness. In case you have discovered or believe you have discovered an asteroid, the Minor Planet Center is the place where you want to go. And this is the official, let me go here. And this is the official place with all the official information for minor planets, so asteroids, comets, and so if you have discovered something, or if you believe you have discovered something, you just come here, minor planet checker, and you just say, listen, I believe I have around these observations, I believe I saw something. Was there something there? And we'll tell you what. Otherwise, you just send them a message saying, you know what, I discovered this. Or of course, you can come here and say, okay, now give me all the objects which are already known. These data can be big, so watch out if you decide to download them. To finish, you may want to have access to some data, and when you want to have access to data, you want to go to archives. And so let me show you just 3 archives which are important. Archive.SpaceTelescope. So this is the website of the Mikulski Archive for Space Telescopes. It's maintained at the Space Telescope Science Institute. It hosts Hubble, Webb, TESS, will host Roman, and in fact all most of the NASA archives are hosted here. I particularly enjoy the science portal. Used to be complex, now it has significantly improved. Let's look for one of my favorite stars, our Corona Borealis. I was checking it before, and you can see there's test data, there's Spitzer data, and here you can select by IUE or by your IUE observations. You can even get, where is it? You can get the longest exposure. I want the longest exposure, right? And then you can look at the spectrum, right? So there you go. In other cases, you can just download the data and you analyze them on your computer. Another very important one, and for us based in Europe, is one of the main resources, is the ESASky. The ESASky is huge. I'll just go to the science portal because it's fun. And again, the science portal, since when it started, it became phenomenal. And if I try to go to M87, there's images, data cubes, and spectra. Let me just show you a data cube. This is news observations, and what I can actually do here is I can actually preview the data set. So this is actually, I am previewing the data set, the data. This is actually the spectrum of this part of M87, which I think is phenomenal. Last one on the list, but not least, and eventually I'll make a video just for it, is ESASky. ESASky, in fact, is much more than a data archive. It actually connects to the virtual observatory. This was not done on purpose, but this is a favorite object of a very good friend, so I will keep it here. And you can do beautiful things with this. So you can come here, you can look for which telescopes have images of this. Wow, there's already images from JWST of this object, and whenever they're available, you could see them, you could look at them. There are, let me see, some observations which may be public, right? And I can make a preview of some, so I can get a preview up here. I can see catalogs which are available for this sky area. I can see spectra and light curves available for this sky area. And the most curious thing is that I can look at this in, say, ultraviolet. Then I can look at this in optical. Then I can look at this in, say, mid-infrared. I wonder if there is Yes, let's go back to all white. And I can play this. So ultraviolet, optical, and mid-infrared, and you can see how the different parts of these galaxies they are seen different ways at different wavelength regimes. All right, so I think at some point I will make a full video about ESASky. Most of these services would deserve a video themselves. Let me know if you have some resources that you think I missed, or if there are some resources that you would like to know something more about. And I'll talk to you next time. Ciao.